In this example, it's normally given, it's normally expressed actually as trial and improvement. Sometimes it's called trial and error, and they are synonymous. It means the same thing. So for trial and error or trial and improvement, what we've got to just do here is throw numbers into this expression and see if it gets 5. So first thing is to put a number into x that you think would work, would give you a number that's close to the right answer. So a number cubed, that means some number times itself and then times itself again. So if I were to put 1 into this, I'd get 1 times 1 times 1, and then add a 1 to it, that would be 2. So if I put 2 into that, I'd get, oops, not 2. If I put 1 into that, then I get 1 cubed plus 1 would equal 2, and that is too low. So then, because it's too low, I have to try one bigger. So I try x equals 2. And 2 cubed plus 2. 2 cubed is not 6. That is 2 times 2 times 2, which is 8. And then add the 2 is 10. And that is too high. So now I know that my number has to be between 1 and 2. And it could be, well, the first thing to do is actually try the midpoint. So it's going to be 1.5. So on a calculator now, you'd have to do 1.5 cubed plus 1.5 and find out what that is, which is 5.0625. And that's nearly right, but it's still a little bit too high. Now we've done our upper and lower and midpoint, we can now just choose roughly what we want to do. So we could try x is 1.4, or we might find that that's too low, in which case we do x equals 1.45 and so on. And we could keep going indefinitely. And what this question is actually asking for is to solve it. And we would never be able to solve this equation using trial and error. So it really should say solve by using trial and improvement. And it should say here correct to 1 decimal place. And if it said 1 decimal place, then we would say which one is closer. Is it the 1.5 or is it the 1.4? We could determine that actually by doing the 1.45 and then saying which one's closer as a result of that. But it's probably better to find the difference between this and your 5 and find out which one's closer. Is it this one or is it this one? So here's a better sort of presentation for this. If you've got to try to solve this equation, giving your answer to 2 decimal places, it actually says that now. We could write it all in a box. So they've tried 1, they've put it in, got 1, and that is greater than 0. So they've concluded that x has got to be then greater than 1. So then they've tried 2. They put 2 into this, and they've got the answer 0.4142 roughly, to 4 decimal places at least. And that is again too big, it should be 0. So then they know that x has got to be greater than 2. And then they try 3, and they find that it's negative and that's less than 0, so therefore the x value must be between 2 and 3. Because they've found it's between 2 and 3, they then choose the midpoint. You get a mark for doing the midpoint, you have to go halfway between these two. You try that, and then you can determine that it's got to be greater than 0. It is greater than 0, so it's got to be between 2.5 and 3, and then you can try your 2.6 and 2.7. And when you do the 2.6 and 2.7, you find that one is greater than 0 and one's less than 0. And then you would use your you would say which one is closer. So is this one closer, or is this one closer to 0? This one is closer. So then you would say that the answer is 2.6 to 1 decimal place. But the question's asking for 2 decimal places, so you've got to keep going. And that's what they've done. They found that between 2.62 and 2.61, there was a difference. One was less than 0, one was greater than 0, but which one was closer to 0? Is it this one, or was it this one? This one is closer to 0. So then they've determined that this one is correct to 2 decimal places. So then your answer would be 2.62.